Hey, it's Tony from Adafruit, and in this video we're going to look at how to draw shapes and graphics on pixel-based displays with MicroPython. So in the previous video I showed how to use the ILI 9341 TFT LCD display, just a tiny little feather wing shield, for example, that gives you a nice little LCD. So there's a 320 by 240 pixel display on here that you can draw pixels on. But the problem is you can only draw pixels, which gets a little bit boring. So, if you want to manually draw each of your graphics, you could do that, but it takes a lot of work. So in this video, we're going to look at a little library that I created that lets you draw just simple shapes like a line, a rectangle, a circle, a triangle, and you can make filled versions of those shapes like a filled circle or a filled rectangle, and draw them on any pixel-based display like the ILI 9341, or we'll even see you can use things like the Charlieplex display, the LED matrix, even like a NeoPixel matrix. As long as you can plug in a pixel function or your display has some way to set pixels, you can use it with this library and start drawing basic graphics on here. So let's just kind of dive in and we'll get started with this. Let's see, we'll go to the main view. So we'll do the desktop. And let's see, let me open up the web browser real quick. So of course for this guide, or for this video, there's a guide that goes along with this. This guide, it's not published just yet, so once this guide is published, then I'll make this video public. So hey, if you're watching this live, you get to see a little preview of a new guide that's coming out soon. And this is the guide, and I'll put a link in the description when this goes up on YouTube, so look down below and you'll see a link to this guide that gives you all the details on what you need to do to actually use the software and the hardware for this. So, and then on the upper right hand corner here, this is, like I mentioned, this is the TFT feather wing. So there's a little display right here, and oh, my cat is trying to jump up here, so we might have some cat helping out with the video here. Anyways, this is a little LCD display, and then connected to it is an ESP8266 Huzzah feather. So this is basically just the ESP8266 processor, but in the feather form factor, so it just plugs right in. I did a whole video, the previous video, on this display and how to make it work with MicroPython. Well, my cat is trying to pull my arm down now. She wants to play, unfortunately. So hey, we're gonna play with LCDs right now. So so calm down. Anyways, though, so that's what we're going to use here to demonstrate this graphics library and just the basic operations. We're going to make it draw different graphics on this display right here. And then I'll actually show you another display. So like I mentioned, this is the LED matrix. So there's 16 by 8 little grid of LEDs, those little kind of white circles that's encased inside of this like epoxy, I think, encased like that. But it's a nice little dense kind of display, real bright because these are LEDs, so each one has a little bit more brightness compared to like a TFT or an LCD display. And then another type of display is like the Charlieplex matrix. So this is kind of similar to the LED matrix. This is just a bunch of LEDs, but there's a different driver that powers these. It uses a different number of pins, and it can actually PWM, or modulate the intensity of each of these pixels individually. So just a different type of display, basically. But again, these are all pixel-based displays. Like, each of the elements of the display is a binary, like an on or off, or it doesn't have to be on or off. It could be a color. It's like a small square that makes up a big grid of a larger image, basically. So we'll come back to these. And another example too would be like a NeoPixel grid. This is the NeoPixel shield, an Arduino shield actually, but this one I've put a feather on the back of so that I can run a MicroPython script with this and control this NeoPixel grid. So again, this could use this graphics library to draw shapes, and the shapes that the library supports. So I ported over this library called GFX, which is our Arduino library, our graphics library. So if you've used even like this display, you can use this TFT Featherwing in Arduino, and you'll use the GFX library internally. And so that library has line drawing, circle drawing, rectangle drawing, triangle drawing, even more advanced things like text drawing and stuff like that. So I've ported over just the basics, so the line drawing, rectangle, circle, and triangle drawing, and then both like a solid, like a filled version, and an empty or just an outline version of those shapes. I didn't implement yet, there's like a round rectangle that'll round the corners on a rectangle. And I think, and the text drawing functions I don't have in the library yet either, because there's actually a separate library that I did that does text rendering in a very, very similar way as this graphics library. So if you want to do text, check out, I'll put a link to the video in the guide that talks all about how to do text on these pixel-based displays. So you can do that actually with a different library for this. So let's just kind of dive in. The hardware that you need for this, like I mentioned, for this guide, there's no real special requirement. You just need something that has a pixel-based display. So something that has a MicroPython library that you can call a function to set a pixel. So like this TFT has a pixel function, the Charlieplex, the OLED, I didn't mention that, the OLED Featherwing, that's a really nice one that's pixel-based that you can use to draw graphics on with this. So all kinds of options for this. And I mean, you could make your own thing too. If you had like a big grid of servos that are controlling like, you know, maybe a mirror or something that's reflecting light. If you've ever seen some of those big displays, they're like a bunch of little mirrors and a little servo behind them that just kind of move the mirror so that it'll reflect light or not reflect light. And then you can do all kinds of cool animated effects. You could power that with this library because it just needs some kind of function to set a pixel. And I'll show you more about that as we get into the code for this. Okay, so, and the very first step, of course, get your hardware set up. Like I said, I'm using the ESP8266 and the TFT Featherwing. I've already loaded onto this ESP8266 MicroPython. Make sure you get the latest version. And then I've also loaded up the ILI 9341 display module. And so I linked to all the guides on the previous page here. So again, follow these guides to get all of that libraries and things set up. You know, before you go on, make sure that you can actually manually set pixels on this display and then look at using this library, because, you know, it's easier to troubleshoot things in isolation rather than putting it all together and then it's like, oh, it doesn't work. You know, break things out into separate parts to see what's working and what's not working. Okay, the important thing then for this module and for this guide is this little GitHub repository here, the MicroPython Adafruit GFX module. So this one right here, and I'll put a link in the description below, and go to the guide. This has a link to this this repository also. So this has the code, this is MicroPython code to do that basic graphic and shape drawing on any kind of a display. And the important thing that you want to do is go to the release page, find the latest release, and download the gfx.mpy file. I've actually already downloaded this, but grab this file, and then you need to copy it onto your board. So in my case, because I'm using the ESP8266, I'm going to plug it in so that it's connected to my computer. There we go. And you'll see, oh, actually, I forgot, this ESP8266, I have a main.py loaded on here already that's actually running a little graphical demo. So this is actually an example that eventually you'll be able to do with this library. But I'll show you, let me clear out that main.py. So I'm going to use the ampy tool, and I'm going to remove the main.py from my board, which I think this will work. Sometimes this doesn't work, I've noticed, when it's running a main.py script like this. So, okay, yeah, this doesn't look like it's working to remove this. Let's see if we can connect to this board, the serial REPL. And again, because it's running this main.py, I'm not going to see anything. If I control C, I can at least I can stop everything from running. It's in the raw REPL. So now if I press Control B, as in boy, this gives me back into the normal REPL. And then I'll show you, if I just want to manually get rid of that main.py file, I can import the OS module, and I believe os.remove, and if I just give it main.py, this should remove my main.py, and if I call os.lister, and now I see, okay, I don't have that main.py on here anymore. Okay, so, and now if I just reset this, if I unplug it and plug it back in, now we're back at kind of a default state for this board. So this is as if I had no main.py, you know, no code running earlier. So you just got a quick little example of how to remove the main.py if you have trouble doing that. Okay, so like I said, the ampy tool is kind of handy. I can use ampy ls. This will list all the files that are on my board. I already have this gfx.mpy file on here. And by the way, if you haven't used ampy much and you're wondering like where is the serial port? Why am I not specifying that? I've set the environment variable ampy_port, and so this is set to my Scilab's USB to UART, which is what the little USB chip on this ESP8266 uses. So I set this environment variable ahead of time, and that way I don't have to specify it every time I run an ampy command. But if I want to put that gfx.mpy, which is in my downloads folder, I can just run the ampy-put command, and this will just overwrite the file. It's already there, but it's fine. You know, I can overwrite it, and it's not a big deal. And then also notice I have the ILI9341 and the RGB.mpy files on the board already. That's actually the code that drives this display. So I need both the display driver code and then this graphics library, the gfx.mpy, to work with this. Okay, so once you copy the code over, then you want to connect to the REPL on your board, and like you could use a serial REPL like this connection. You could use the web REPL with ESP8266. Whatever you want to use is fine. And in this case, first I need to initialize the display, and I'm going to rush through this really fast because I've already shown how to do this on the TFT Featherwing video. So go back to that, and it goes into more detail about what this means. But basically, I just need to import the machine module and the ILI9341 module, and then I need to create an instance of the SPY bus, and be careful to use hardware SPY by using that magic 1 parameter. And this is going to use 32 megahertz if I got the correct number of zeros. Oops, a little too many zeros. There we go, 32 megahertz. And then I'm going to create my display, and this is an instance of the ILI9341 class, which needs to know the chip select line, which is digital input 0 on the ESP8266 board with this Featherwing, and then the data command line, which is pin 15 for this board. Okay, and so now you see the display just kind of initialized itself, and I can clear the display. If I fill it with the value 0, now it goes all black, and basically it's ready to go. And when I draw a pixel, right up here in the upper left, this is the origin. This is the 0, 0 position. And then over here is position 240 in the X dimension, so 240 pixels across. And then down here is position 320 in the Y, so 300 pixels, 320 pixels tall, basically for this display. So it's good to know because you want to know the dimensions of that, because now you're ready to initialize the graphics library. So the way to do that, you need to import that GFX module, and inside of the GFX module is a class called GFX. And so I'm going to create an instance of that, and I'll assign it to something called graphics, and I want to create the gfx.gfx class. And now I need to tell it the size of my display, like the maximum X and Y dimensions. And so like I said before, this is 240 pixels across by 320 pixels down, so in the Y dimension like this. And then the magic thing that I need to do is tell it how to draw a pixel. So I can tell it which function to call when it needs to draw a pixel, because it will give me a simple, like a line drawing function. If I want to draw a line across the display, it will go through and pixel by pixel draw each of the pixels in that line, but it has to know, how do I draw a pixel on this TFT display? You know, there's a special pixel function I need to call on the display object, versus like if I wanted to use this with the LED matrix, there's a totally different pixel function that I need to call on here. So rather than have the library try to know about and understand all of the possible displays that it could draw pixels against, it just lets you pass in a function to call that just has to take in an X and a Y position and then some number of optional color parameters that it will use when it needs to draw that pixel. And that's kind of the power of MicroPython, in that a function is just another entity that you can pass around as a parameter. You can create functions on the fly. You can send a function as a parameter. You can take that parameter and save it on a class and then use that function yourself internally. So that's really powerful. And you can do some of that stuff in C and in Arduino. It's a little more cumbersome in some cases, and it's certainly not as dynamic. You can't just create a function interactively at a REPL like this in Arduino. So that's really kind of the cool thing that's happening here with MicroPython. So I'm going to tell the graphics library that my display.pixel function is how it should draw pixels. So when it needs to draw a pixel for a line or a square or a circle or whatever, it's going to go to this display object and call the pixel function that's on this object. And I showed more about that in the TFT video and guide, where I show you can manually call that pixel function to draw each of the pixels. So okay, so I'm going to do that, and nothing happens because it's just initialized this class. And at this point, I'm ready to start drawing things on my display. So I have a few high-level functions that just give you these basic drawing primitives. So a really handy one is graphics.line. And so the line function will draw a line between any 2 points on the display. So let's say position 0, 0. So this is the first point, which will be in the upper left-hand corner here. And let's draw a line just that goes all the way down to the very bottom of the display here. So that would be position 239 and 319, because it's 240 pixels across, but if the first row is row 0, or column 0 rather, then the last one is column 239, not 240, because that 0 row counts as 1 in this case. Okay, so that should draw a line like that. And then after you specify the 2 points of the line, any other parameters that you specify will just be passed along to the display.pixel function. And this is how you specify color. So it would be as if I was calling display.pixel, and I don't have to worry about the X and the Y position to that function, because my line function here is going to figure out all those X and Y positions. But whatever I put after my 2 points right here, anything that comes after this point will just be passed along as color data. So in this case, to specify color, in the ILI 9341 module, there's a color 565 function, and you just specify the red, green, blue component color values. So like 255.00 is full red, so 255 red intensity, which is maximum intensity, 0 green, and 0 blue intensity. Go back to the ILI 9341 TFT video and guide where I explain a little bit more about what this color stuff means. But basically, this is just how I'm specifying the color of this line. And this might be different between each library. So, for this little LED matrix, it doesn't have a concept of color. Each pixel is either on or off, a 1 or a 0, a true or a false. So instead of this ILI 9341 color, I would just specify a 1 or a 0 if I wanted to draw an on or an off pixel for that line. So, and we'll come back. We'll see an example of that after we do some of this line drawing stuff, or some of the other things here. So cool. Just notice I ran this, and a line just drew itself across the display here. And let's draw another one. Let's draw a line from, let's go from, how about from the other side? We'll draw a big X. So let's go from 239.0 to 0319. And let's keep it red. So as I run this, now watch, boom, it just draws another line like that. So that's cool, and you can draw a line from anywhere to anywhere on this display, and the function's smart enough to figure out how to draw that line, and it'll get the right kind of rate of change, and it uses an algorithm called Bressenham's algorithm that's a pretty well-known kind of algorithm for computer graphics line drawing. So that's kind of handy, that's useful, but there are other functions, and if you want to clear the display, remember the display.fill function with a value of 0, that will just clear out the display. Okay, so I have a rectangle function, the rect function, and this takes in the top left corner of your rectangle and then the width and the height of your rectangle. And this will draw an empty rectangle, just like a 1 pixel wide border around this. So let's say position 10, 10, and 100 pixels wide by 100 pixels tall. So this will be a square, and we'll make this ili9341.color, and let's pick a green color for this rectangle. So I do that, and you can see it just drew a rectangle here, and it's position 10, 10, so it's offset a little bit to the right and down, and then it's a square, so it's just 100 pixels by 100 pixels. So simple, pretty easy and straightforward to do that. There's also a filled version of this, so fill underscore rectangle, and this will just draw a filled in rectangle. Exact same parameters, so the X and the Y position of the upper left-hand corner, the width and the height, and then the color. And so I run this, and you can see it's going through and it's drawing this. Now, you'll notice this is not the fastest thing in the world. This is pretty darn slow, if I'm honest. And there's a reason for that, so I'll show you how to actually speed this up in a moment. But what's happening here is basically it's MicroPython code that's implementing this fill rect function. And if I go to that code, I'll actually show you. This is the code for the library. You can see this on GitHub. It's all open source there. So if I go down to the fill rectangle function, what it's doing is it's actually just going through for each of the columns. It's drawing a vertical line, and you could actually see that draw each of these lines across here. So this is just pure Python code that's powering this right now. And this vertical line drawing function is actually also pure Python code. It's this slow vertical line function right here, where it just goes through each of the pixels in that vertical line and turns them on individually. Now, I'll come back later to explain more about why that's slow and how you might be able to speed it up, because basically, to draw this filled rectangle, it has to go through every single pixel and do a little spy transaction to the TFT featherwing here to tell it, hey, turn on this pixel, now move over and turn on this pixel, move over and turn on this pixel. And that's slow, that's not very fast. It would be faster if you set a big chunk of memory at once and then just told the display, okay, here's a line of data, set it all to this color. And I'll show you how you can do a little optimization to get that effect. But just realize, this is not super fast because this is all Python code. You could speed this up by putting this into a native like C module that just implements, like here's the line drawing function, for example. Again, notice it's all pure Python code, which is kind of cool. Like it's easier to read and understand this code, but it's not going to be as fast as if you did an implementation of this in C. Now, if you did it in C, it would have to be compiled into the MicroPython firmware as a built-in module. And eventually we might do that because for like this display especially, when you have a lot of pixels, you want the drawing functions to be fast. If you have a little display like this that only has 16 by 8 pixels, that's not many pixels, so even if you have to draw a line pixel by pixel, it's going to be pretty quick. Versus these higher density displays, you're going to want some faster functions. But all hope is not lost. I'll show you a way to optimize this in a moment here to make it a little bit faster. But anyway, so that's the rectangle and the filled rectangle. Let's clear the display, display.fill 0. And I'll show you there's also a circle drawing function. So this takes in the X and the Y position of the center of the circle. So let's make the center of the display. So that would be 120 on the X and 160 on the Y. And then it takes in the radius in pixels. So let's say 30 pixels, kind of a small circle. And then the color, again, anything after this is just forwarded along to the pixel function. So we'll do the color 565, and let's make this a blue circle in this case. So I do that, and you can kind of see it just drew a little circle, 30 pixel radius circle right in the center there. So that's perfect, that's a handy little function. And surprise, surprise, there is a filled circle, fill_circle version of the function. Exact same parameters, you run that, and it's doing exactly what you expect. It's filling this in. And again, notice it goes vertical line by vertical line as an implementation of this. And it's slow right now because the vertical line drawing is kind of slow on this display. So, okay, so that works. And then let's do a clear of the display real fast. And then let's go through and let's do the last primitive drawing function is a triangle. So I can do display.triangle, and you need to pass it 3 points, and it'll draw a triangle around all 3 of those points, a 1 pixel wide triangle. So let's pick the points. How about the center, 120, but then we'll go up from the center a little bit, 60 pixels. So 120, 100. Then the next point, let's go over to the right. So let's go 180, how about, and then 160. So we're over to the right and down a little bit. And then let's go, how about 60, 160. So now we're on the same horizontal line, but way far to the left. This will make more sense when you see this triangle rendered. And then after this, the color data that you want to specify. So we'll call color, and let's do a pink rectangle. So red and blue intensity turned on. So I do that and it fails. Oh, that's because I'm trying to call this on the display object. Remember, I have to use the graphics object because the graphics object is what actually has the algorithms for all of this drawing. So I want to call the graphics.triangle function here. And there we go. So there, it just drew a nice little triangle right in the center of the display like that. And of course, there is a filled triangle version of this. So fill_triangle, exact same parameters. And I bet you can guess what it's going to do. So I call this, and now you can see this one's actually using the horizontal line drawing to render this triangle. So, and it takes a little while. Again, it's not the fastest thing in the world because it's going pixel by pixel for this. But it works. Like, you can draw a simple little triangle like that. So that's pretty cool. That's pretty handy and an easy way to draw graphics on these displays. You can make like a Pong or a Breakout game just by drawing rectangles and a circle. So have, your little player down here as a rectangle and maybe like another player up here, or even like, if it's Breakout, then you have a bunch of squares up here and then have your little circle and have it, bouncing around the display and knocking things over. So that'd be fun to try and implement that using this. And you could do that against like a giant NeoPixel grid, maybe against the side of a building or something. You could play Breakout for miles with a huge NeoPixel display. That would be a lot of fun. If you do that, definitely come and show on Show and Tell that project, because that would be an amazing thing to see. Okay, so let me show you an example. I'm going to close out of the serial REPL. In the library code, there's an examples folder, and I have a couple examples in here. So this test example, and I'll open this in my text editor, so it's a little bit easier to see it and read it. So this is an example for the TFT Featherwing and ESP8266, but you could change this to work with other displays. You just need to adjust how the SPI bus is initialized and how the display is initialized right here. But this example just goes through and it just shows off drawing each of these shapes. So I'm actually going to run it, and I'll use the ampy run command. Let's go examples, ILI9341, test.py, and you'll see it's actually going through and it runs. It'll draw a line, wait 2 seconds, it draws the rectangle, it's drawing a filled rectangle, waits a few seconds, now it's drawing a circle, and then it's going to draw a filled circle, so you see that, and then it's going to draw a triangle, and then a filled triangle. Now notice how much faster this triangle and this circle and this square rendering is. If you go back in the video, and when I was running this at the REPL, it was at least half as fast as this, maybe even slower. This is noticeably faster, and so you might be wondering, okay, how did I speed this up? So if you look at the code for this, there's a different way that I'm initializing this GFX object. So before, I was calling the gfx.gfx class. I'm creating an instance of the GFX class. I'm passing the dimensions again, 240 by 320 pixels. I'm passing the pixel function, but then I'm also passing these optional H-line and V-line functions. So these are, if you have a faster horizontal line drawing and vertical line drawing function, you can specify these functions, and the graphics library will use those faster functions when it's doing things like drawing this filled in circle, or when it draws like the filled in triangle in a moment here. And so that's why, that way, if you have a faster implementation, you can tell the library, hey, don't try and draw this thing pixel by pixel, use my faster function. And that function, so you can see I actually define those functions right up above in the example right here. So I have a fast H-line and a fast V-line function. And these are just calling the fill rectangle function on the display object itself, because this ILI9341 library, it has a function called fill rectangle built in, and it's a little more optimized. It doesn't go pixel by pixel. It figures out which chunk of display memory it needs to write to, and just does a more efficient write to that display memory so that it draws an entire horizontal or vertical line in less SPI transactions, less calls, less things that MicroPython has to do. And if you notice, it helps. This is much faster. It's certainly not, you're not going to do like Doom, or if you do, then I'd love to see it, because that would be amazing, but this is, you're not going to make a fast action game with this, but you could still do some cool things. Like this is perfect for making like a simple interface. If you use the text library that I showed in a previous video, you can draw text and have like some graphics and things next to it, draw some shapes and stuff like that. So just basic things are what you could do with this. And if you really do want to do like a video game or something like that, all is not lost with MicroPython, but you'll probably want to look at something more advanced, like implementing your own graphics functions in C and building that into the firmware. So maybe a future video we might look at doing something like that. But for now, this will kind of get you started with kind of this basic graphic drawing. Okay, so the last thing I wanted to show, and we'll rush through this really fast. I wanted to just demonstrate using this with a different display. So this is the 16 by 8 LED matrix Featherwing, and I have this connected to the SAMD21 Feather, and this is running our SAMD21 MicroPython port. And so let me connect this up, and I've actually already loaded on this board some stuff ahead of time. So I've loaded the graphics library on here, and the nice thing about our SAMD21 port, it shows up as a drive. So this is a USB drive. So you can see I have the gfx.mpy, and then I have, for this display, it's the HT16K33 matrix.mpy that I need to use this display on here. So I've already preloaded those and it's good to go. And I did a whole separate video on this display and how to use this matrix display, which I'll link to in the description below. So if you've never used this display, don't worry, go check out that video and you'll learn a lot more. I'm going to open up the serial console now for this. So let's do dev tty USB modem 115200 baud. And okay, so now I have to initialize this display. I'm going to speed through this because I've done a whole video on this before. Import machine. I need to import the I2C interface, and that's with the SCL pin and the SDA pin. So we're good with the I2C. And then I need to import the matrix module, HT16K33 underscore matrix. And we'll call this display, how about we'll call this matrix, matrix equals the HTK library dot, and inside of here, there is a matrix 16 by 8 class that I want to use. And this just needs to take in the I2C interface. I do that, you get a whole bunch of random junk. That's because it initializes with random display memory. You can clear all that by basically calling matrix.fill0 and then matrix.show. This is one of these displays where you edit the frame buffer, you edit the display in memory and like by setting each of the pixels, and then you call the show function to actually update the physical display. So if I want to set a pixel, I can call matrix.pixel 00. For this display, it just takes a 0 or a 1. A 1 means on. So this will turn pixel 00 on. And just to show you, let's put matrix.pixel10. So the pixel 1 in the X dimension over from it. So we'll set that. And then again, remember, I have to call matrix.show. And so notice here, the way that this display works, the origin is in the upper right, and your X dimensions move in this direction. It's fine. The graphics library doesn't care how your origin works and how, which way you move. You just need to be aware when you're rendering the graphics that, this display is 16 pixels across, but it goes from right to left. And then it's 8 pixels down in the Y dimension. And I could flip this if I wanted. I could make a pixel drawing function that just flips my X position to be over here. And if I want to do that, hey, let's do it. So let's make a matrix underscore pixel function that takes an X and a Y, and we'll say a color. And then this should just call matrix.pixel, and it just needs to invert my Y position. So I want to take 15, or my X position. So I want to take 15 minus X. So that, basically, if I say I want to be at position 15, which, I really want it to be over here on the far right, then that's, 15 minus 15 is going to give me position 0, which is right over here. Whereas if I'm at position 0, that's going to be 15 minus 0, so it's going to be on this far left side. It'll make more sense when I call this function. The Y I don't need to change because that's still going to go up and down. And then the color I'll just pass along to the pixel function. Okay, so now with this, let's do matrix.fill0 and just matrix.show. Okay, it's cleared. And then let's call our matrix underscore pixel function, and we'll say 00 and a color of 1 for this. And now I call matrix.show, and there we go, upper left. So okay, this is our new origin, just based on having our own pixel drawing function. So that's kind of a handy thing. You can use this to change how you're drawing on your display. Like if you need to rotate it in some way, you can make a pixel drawing function that does that rotation for you. Okay, so let's import that GFX module now, the graphics module. Let's create an instance of the graphics class. So this is gfx.gfx. And this needs to take in the width, which is 16 pixels across, the height, 8 pixels tall, and then my pixel drawing function, which I created before, matrix underscore pixel. Now I don't have an optimized horizontal and vertical line drawing function for this one, which is okay. It's a small display. I don't think it matters. So I'm just going to leave those out and just create this as is. Okay, so let's clear our display. We'll say fill with 0. And let's try to draw a line. So let's do graphics.line. Let's go from 0, 0, the upper left, to the bottom right down here. So that should be 15, 7. And then the color, I don't have to call some function to generate a color. I'm just going to say 1. That means turn on the pixel, basically. So I do that. Nothing happens, because remember, you have to call matrix.show. And there we go. We've got our line drawn across there. That's pretty cool. And if I wanted to invert this, I could say, okay, how about matrix.fill1, So that's going to set all of the pixels on. And let's draw that line again, but with a value of 0 for the color. And now when I show this, it's inverted. So I've got, a black line against a white or an on or a lit background like that. And the display, it's not really flickering in real life. This is the refresh rate from my camera. When I look at this with my eyes, it's not flickering. It looks good. So it's just a weird little artifact. Okay, cool. So let's just do one more little thing to show you that, this is kind of the power of this graphics library. We'll set all the pixels to 0, and just to show that they're turned off, we turn them off. And let's draw a tiny little circle, because, I don't have a lot of pixels here, so, there's only so much I can do. But let's say graphics.circle. Let's try to put it in the center, which would be about 8, 4, somewhere around there. Let's say 3 pixels radius, and then 1. And then let's call matrix.show, and look at that, we've got a circle right in the center there. So that's pretty cool, just simple. And you see, this is pretty fast to draw this circle because there aren't a lot of pixels. And even though it's going pixel by pixel, it's only 20 pixels. You're not really going to notice that difference unless you're trying to do like super fast animations with this. But this is perfect. Like you could make, maybe a little Tetris game or something. You could even do like Breakout on this. That'd be kind of a fun game to do on here. Again though, you could use other displays like the Charlieplex display or even the NeoPixel display. And if you go back to the font rendering video that I mentioned, there'll be a link in the YouTube description. I show how to use the font rendering module with this NeoPixel shield. And the exact same way that I did that by creating a pixel drawing function for the NeoPixel shield would work with the graphics library here too. So if you want to draw graphics on a NeoPixel shield, go to that font rendering video. At the end of it, I show a function to draw on a NeoPixel grid, like a 2D pixel function. Use that function, and you can use this graphics library to draw graphics and things on there. So cool. So that's it. I think if folks have questions, throw them in the chat, and I'll see if I can get to them. We'll jump back to the main headshot. And yeah, folks are saying there's no cat. Yeah, my cat, she just ate, and she wants to play now. So it's cat play time. I don't know where she went. She ran off. But normally she's back there, but not tonight. So okay, so I don't see any questions, so I'll wrap it up then. This is the MicroPython displays drawing graphics video. I have a little bit of a brain fart there. I have to remember what I just did. But this is how to draw graphics on a pixel-based display using a nice little module that I created in MicroPython. And so this is a nice generic module. It's pure Python, so you can save this as a .mpy file and load it onto your board in its like external flash file system. You don't have to compile this into the firmware, and you get basic line, circle, square, triangle drawing commands, the basics for doing some simple graphics and things. So hope you learned a lot from this video. Check out youtube.com/Adafruit. You can see this video, all kinds of other fun project videos. Check out twitch.tv/Adafruit. That's where I like to stream these videos live. I do a couple streams per week. I try to do one on Tuesdays and on Fridays. This week was a little weird. It took a little bit longer, so I had a Thursday stream, one yesterday, and then I've got the Friday stream today. Now next week is Thanksgiving holiday, so actually I don't think I'm gonna have any video streams next week. So we're just taking some time to do a bunch of stuff internally. But I'll probably be back the week after with all kinds of more fun MicroPython stuff. So maybe take the holidays to see what kind of fun stuff you can build with MicroPython, and if you can make some fun graphics projects, come and show them off on the show and tell that Adafruit does. So until next time, this is Tony from Adafruit. So thanks for watching. I'll see you later.